In our last video, we talked about the basic concept of covariance. Today in this video, we'll talk about change in origin or change in scale and the step deviation method to find covariance for a given data. Okay, so let's start. First of all, we'll talk about change in origin and change in scale. Okay, so when we are saying change in origin, we are simply mean change in origin. We simply mean we are adding a number to the given set of observation. Okay, let's suppose there will be a quantitative variable x which has an observations of x1, x2, x3, so on till xn. And when I'm saying change in origin, we are simply saying that we are adding a number to our x's, right? So that is adding a constant. We are simply shifting the origin by adding a constant. And when we say change in scale, we simply mean we are multiplying a constant with the variable. So, when we are saying let's define a new variable u which is equal to ax plus b. So this b represents change in origin because we are simply adding a constant to it. And this a represents change in scale because we are multiplying each observation of the variable with a particular constant. So this is change in scale. Now let's see that does this change in origin or change in scale impact our covariance or not, and how can we use this particular characteristic to solve questions in a more easier way. Okay, so first of all, let's see the relation between the covariance and the change in scale and change in origin. So, okay. So, first of all, let's define the variable u is equal to ax plus b. Now, if I ask you u bar, what is u bar? U bar is summation of ax plus b upon n, right? This is the mean. So, this is what we require in actual, right? So, similarly, also let's define another variable v which is equal to cy plus d, right? Where c is again changing the scale and d is changing the origin for our another quantitative variable y, right? And if I ask you what is v bar, we simply say it is summation cy plus d upon n, right? We are simply finding mean for u, the new variable u. Okay, so this becomes a summation x upon n plus we are summing at b n times, so n into b upon n, right? So this becomes a x bar plus b. Similarly, v bar is equal to c summation y upon n plus n into d upon n. And this becomes v bar is equal to c y bar plus d, right? So let's just write down the formula. What is the covariance between x and y in general? In general, covariance between x and y is simply equal to summation x minus x bar into y minus y bar upon n, right? In general, this is the covariance between x and y. Now let's see what will be the covariance between u and v. If the formula turns out to be same, then obviously there's no impact of change in origin and change in scale. But if it turns out to be different, then there's an impact. So let's talk about it. Okay, so covariance between between u and v. So what will that be? That will be summation u minus u bar into v minus v bar upon n. So what does this mean? This means summation u. What is u? Ax plus b. And what is u bar? U bar we have already computed here. This is our u bar. So this is minus ax bar minus b. This into v minus v bar. What is v? V is simply cy plus d minus v bar, which is cy bar minus d upon n. Right? So now this and this cancels out. Similarly, d and minus d cancels out. We can say summation. Can we say a into x minus x bar into, then again c is a constant, so this becomes y minus y bar upon n. So since a and c are two arbitrary constants that we have multiplied in order to change the scale, we can take them out. A into c, then is summation x minus x bar into y minus y bar, this upon n. So now what is covariance of u and v? Can we say this and this term is similar, just that we have our two more constants, that is a into c into covariance of x, y, right? So what we are saying over here is, we are simply saying that this particular term is same as this term. So thus we have replaced it and we get a into c into covariance of x, y. So what can we conclude from this? Now see, b and d were the two terms that were used in order to see the change in origin. But is there any b or d over here? No, there's no b or d over here. So it means that there's no impact of change in origin on the covariance. But we do have two constants a and c, where a was representing change in scale for variable x and c was representing the change in scale for variable y. And we have both these a and c over here. Thus, covariance is independent of change in scale but not for independent. Covariance is independent of change in origin but not independent of change in scale. Right? So now, how can we use this? So, since covariance is independent of change in origin, this part we can easily use in order to solve the questions easily. So, basically when we think change in origin, so let's see in another example that how can we use this part of change in origin to solve the questions. So, we'll directly move on to a question. So, here we are given, find the covariance between x and y for the following data, where x is 25, 40, 30, 25, 10, 5, 10, 15, 30, 20 and respective y's are 10, 25, 40, 15, 20, 40, 28, 22, 15, 5. Right? Now, so we have two variables x and y. Let us define a variable u and v where u is equal to x plus a and v is equal to y plus b. Or we can also say this is similar as, or we can also define it as x minus a and v as y minus b. We can define both the ways. Both of these represents change in origin, right? So to solve the question, let's use u is equal to x minus a and v is equal to y minus v, because both of these, what are these two representing? Both of these are representing change in origin, because when I am saying minus a, I am simply subtracting a positive number, or we can also say we are adding a negative number to it. See, it's a arbitrary constant. It can be either a positive number or a negative number. We are simply adding minus a to it, or we are subtracting a from x. See, what happens is sometimes the data provided to us, the observation values are quite high. So it's not really very easy to solve it, right? So what we do is we simply use the fact that covariance is independent of change in origin. Thus, we can easily add a number or subtract a number in order to solve the question, right? So now, what if we take this A as 20? Let's suppose A is equal to 20. And what about B? What should we choose? We can choose B also equal to 20. See, it's an arbitrary constant. Now, what if I express U and V in terms of X and Y? What if I simply find the covariance between this U and V? Can I say it will be same as X and Y? That is, covariance between U and V will be same as covariance between X and Y. Why? Because covariance is independent of change in origin. That is, simply adding or subtracting a number to the entire sets of observations of a particular variable will not impact our covariance, right? So now we can use any of the formula for covariance in order to find the covariance between U and V. Okay, so let's just write down the formula. Covariance between U and V, which is equal to covariance between X and Y, is simply equal to summation U V upon N minus summation U upon N into summation V upon N. This is true? Okay, so let's just simply write down this formula now. Over here, covariance between UV is equal to covariance between XY, which is simply equal to summation UV upon N minus summation U upon N into summation V upon N. We need to find this, where U is simply equal to X minus A and V is equal to Y minus B, where A is equal to 20 and B is equal to 20. Why did I choose 20 for it? See, just look at the data. Can we say 20 is lying somewhere between 40 and 0 over here, right? Similarly, for this data, can we say 20 will be an appropriate figure just to subtract also from all the values? It's quite easy to subtract 20 rather than subtracting other numbers. Plus, we'll get more smaller values when we subtract these, right? Okay, so now let's simply fetch these figures. First of all, let's calculate U. What is U? U is simply X minus A, which is equal to X minus 20, right? So now 25 minus 20 is 5. 40 minus 20, 20. 30 minus 20 is 10. 25 minus 20 is 5. 10 minus 20 is minus 10. 5 minus 20 minus 15. 10 minus 20 minus 10. 15 minus 20 is minus 5. 30 minus 20 is 10 and 20 minus 20 is 0. Let's find out V, which is equal to Y minus B, which is equal to Y minus 20. So 10 minus 20 is minus 10, 25 minus 20 is 5, 40 minus 20 is 20, 15 minus 20 is minus 5, 20 minus 20 is 0, 40 minus 20 is again 20, 28 minus 20 is 8, 22 minus 20 is 2, 15 minus 20 is minus 5 and 5 minus 20 is minus 15. Yes. So next we also need is UV. So that is, we need to multiply U into V. So means this column multiplied by this column, right? So 5 into minus 10 minus 50, 20 into 5 is 100, 20 into 10 is 200, 5 into minus 5 minus 25, minus 10 into 0, 0, minus 15 into 20 is minus 300, minus 10 into 8 is minus 80, minus 5 into 2 is minus 10, 10 into minus 5 is minus 50, and then it's 0 into minus 15 is 0. Then we need is summation of uv upon n. So let's just find out. Minus 50 plus 100 is 50. 50 plus 200 is 250. Minus 25, 225. 225 minus 300 is minus 75. Minus 75 minus 80 is minus 155. Minus 165. And this big minus 50 is minus 215. Then we need sum of v upon n. So summation v is minus 10 plus 5 minus 5 minus 5 plus 20, 15, 15 minus 5, 10, 10 plus 20, 30, 38, 40, and then is 40 minus 20, which is equal to 20. So this becomes summation v is equal to 20. And similarly summation u is equal to 10. So now let's just put in the value. Summation uv is minus 215 upon n. What is n? N is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We have 10 observations. So minus 215 upon 10 minus summation u upon n. So summation u is 10 upon n means 10 upon 10 into summation v upon n, that is 20 upon 10. Right? So this becomes minus 21.5 minus this gets cancelled out and this 0 also gets cancelled out from this, so minus 2. So minus minus, so this becomes minus 23.5. So this is the covariance between x and y. So now you have seen, so earlier if we won't have used this minus 20, don't you think we would have to multiply like some figures like maybe 15 into 22, although it's not very difficult over here, but there are some questions which have data like 68 into 79. So those kinds of data are quite tedious to multiply. So in those cases, we simply use the concept of change in origin and simplify our values. And when these values are simplified, we can simply calculate the covariance. Thus, covariance is independent of change in origin, but is not independent of change in scale. And this concept of change in origin we use in our questions to solve it easily. I hope you like this video. Do subscribe this channel for more videos. Thank you.